Interesting. All right. So it looks like we're getting like really close to totality. So let's take a closer look at the feeds coming in from Australia. Kelly, do you want to tell us what we're looking at and kind of talk us through this?
Yes, definitely. So we're getting really close. So the dark upper left-hand side, you see the moon, and then that little sliver is still the sun, and then the prominence, again, that little stick out of magnetic fields and plasma is at the left. It looks like a little jet maybe coming off of the sun. And as we're getting closer, again, we're trying to see those Bailey's beads, which tells us a little bit of the surface of the moon and how it's peaks and valleys. It's not a perfect polished sphere. It has a history, and we're going to see that shown through the Bailey's beads, and then eventually just go to one diamond ring. And then we will go into totality. So again, we're getting real close, about 2 minutes.
Wow. And you can still see the prominence.
You can see the prominence more and more. And I'm actually seeing a little bit of something also almost directly across from it. There's a kind of a band of activity that happens as these things form, and so it's kind of in that same band. So I think of it as almost directly horizontal, but we'll see as we get closer if that comes out at all, and could see a little bit better. No, we're really getting dark, and so if we're in Australia, it's probably again dropped in temperature a little on that beach that we saw Henry was at, and again, any animals might just start to think that it's nighttime. The air or the light will actually get really it just feels eerie, and it's like your brain knows that something's just not quite right. Like I'm not sure about this. Where did the sun go, and why is it in kind of a different color? And it's getting really, really close, and it's exciting to experience this live with y'all.
Yeah, and we're still glasses on, right?
We are still glasses on at this point in time. You will still be able to see that thin. Yeah. And so we're almost there. Oh, and now it has gone dark. Oh, that's still too bright. We probably should still have our glasses on. But those are the Bailey's beads. And we are going towards those beads, diamond ring, and there we go. There is your total eclipse. So glasses off at this point in time, experiencing this beautiful corona. So that prominence is out there. You see that. You also see on the other side, almost like helmets or triangular shaped flows. So the solar wind is flowing out, and so we're really witnessing that corona there. And as they adjust things, wow, there's just all sorts of structure. So it's not a simple thing, right? It's a very complicated, dynamic, always churning, always moving, always evolving. And you see so much structure out. And this is what hopefully that kite is recording right now, is all of these different prominences, and you almost see loops sometimes. And then again, things that look like they flow out of the picture. That's the solar wind, and that's what connects with our planet. And now we're actually getting the Bailey's beads back. So this will be glasses on again. It was a very short but amazing experience. And again, we're going to have around 4.5 minutes in places in the US. In 2024, but that was beautiful. So yeah, so the Bailey's beads are coming back. We're coming back now into what is more of some more beads coming back. And you can still see a little bit of the corona, but again, we would have our glasses on at this point in time because this is the safest, this or your glasses are the safest way to view the solar eclipse.
Wow, this is just phenomenal. Absolutely spectacular.
It is amazing.
Wow. How many eclipses have you seen?
So I have seen 2 total eclipses in person.
Wow.
Yeah, and each one this is magical, and there is just something about experiencing it that is surreal. Oh wow, yeah. So
Yeah.
there's the prominence and all of the other type of mass that's just kind of hanging out there and playing on the loops, the magnetic loops of the sun, and um, yeah, it's beautiful.
That is absolutely phenomenal.
Yes, and this activity kind of picks up as we go towards solar max, and so with predictions right now, solar max is somewhere between 2024 and 2025. So we could have a very active and really structured and a lot of different things on the sun as we have our total eclipse in 24 and our annular eclipse in 23.
So can you talk us through that a little bit? So you're talking about solar max. So the sun has cycles, the solar cycles. What's the difference, and what does solar max mean? And
Yes, yeah. So the sun has cycles in its magnetic energy. What happens is basically the magnetic fields get twisted, and then suddenly they have to just break and relax. And so the minimum is when they're relaxed, and the maximum is as they are getting more and more twisted and more energy to blow off the steam through coronal mass ejections. Those again, 80 million school buses racing towards us at millions of miles an hour, or the solar flares or the energetic particles that the sun gives off. And so this cycle, that going from that really relaxed magnetic field to really tense, it takes 11 years to complete. So you end up going around 5 to 6 years to a maximum, and then back to a minimum, and back to a maximum again. And we're headed towards a maximum in 2024, 2025. And so that's, again, we're going to have a lot more activity, more flares, more coronal mass ejections, and those energetic particles.
well, okay, so let's keep watching as we take a few more questions. Here's a really good one. Aaron Polito on YouTube asks, "What useful data does NASA get, and what do they do with it from observing eclipses?"
That's a great question. And we take all sorts of different data during eclipses. There will be an announcement soon of things that we're specifically doing for the 24. But for instance, for the kite that is flying in Australia today, there will be a spectrometer. So there'll be data from that, and that will all have to go into an archive for NASA and to make sure that's open and available to folks. So any of the things, any of the data that is collected from a NASA source will then be available to use for anyone shortly after it is collected.
Oh, wow. Okay. And I've heard that eclipses provide kind of like a perfect scientific environment for taking measurements if we're trying to do certain types of measurements. Why is that?
It is a really great environment in terms of we don't normally get to turn off the sun on things regularly. We don't get to snap our fingers and just turn night to day or day to night. So for instance, in 23 and 24, we will launch rockets into the eclipse and be able to study our ionosphere, which is a layer of our atmosphere where a lot of our communication signals go through. And if that gets disturbed from a day to night transition, we get to be able to study it very easily during an eclipse, because that's, again, like a very specific time where we know it's going to happen, and we know and we can study those effects, and that's a very known time to do these things. So it's great to have as an experimental laboratory for us.
Yeah, that's so cool. And I love that. Like, we don't get to turn off the sun. That is so true. Okay, so an Arctic Floof on YouTube asks, once totality has happened, how long will it take for the sun and the moon to be back to their normal, and I'm using air quotes, positions?
Right. So this will take about another hour or two to move the moon off of the sun, or the what will then be look like two separate things again.
Okay.